Hey guys, welcome back to another video. Today, we'll be covering a question on linear law. This question from the O-Levels 2020 Paper 2 Question 6. The table shows the three significant figures, the population P, in millions of a country on January 1st at intervals of 5 years, from 1995 to 2015. The variable x is measured in units of 5 years. The first part of the question asks us to plot ln P against x. So firstly, we will need to make a table to record our values of x and ln P. All you have to do for this is to insert the value of P from the respective value of x into ln P and write it to 5 significant figures. Next, we can start plotting the graph. I'm using a graph sheet provided by a 10-year series to help me with this. I apologize if the intervals for the x-axis look weird, having 15 squares per interval instead of 10 usually. First, plot your points onto the graph, and next, draw a best fit line that intersects all the points such that it looks like a straight line. Although this part of the question does not require it, you should just quickly label the points you will need to find the gradient later, and also the y-intercept just to make things easier. The graph plotting is done. Next, the question asks us to find the gradient of a straight line, and hence express P in the form a e to the power kx, where a and k are constants. So from the graph, we just find our gradient, which will approximately be 0.125 to 3 significant figures. Since graph drawing can differ across the cohort, don't worry if your answer is different from mine. While you're doing this, also just jot down your y-intercept as well, as you will need it in the next part of the question. Next, you will need to express P in the form of a e to the power kx. This involves some manipulation of the equation of the graph. Firstly, we will need to change the form of the equation from the logarithmic form to the exponential form. Next, using an indices addition law, we can separate e to the power 1.20 from e to the power of 0.12453x plus 1.20. Hence, from this we can deduce that a is equal to 8e to the power 1.20, and calculating should give us 3.32 to 3 significant figures, and k is 0.12453, or 0.125 to 3 significant figures. Now, the third part asks us to find the first year of the interval in which the population first exceeds 8 million. This part is simple, as all we have to do is to substitute p equals 8 into our equation we go from part 2 and make x a subject. We will need to change the form from exponential form to logarithmic form while we make x a subject. Under some calculations, the value of x should be 7.0620 or 7 when rounding down. This means that 35 years will have passed as 7 times 5 equals 35. Hence, the first year of the interval in which the population first exceeds 8 million is 2030. And the question is done. I'll be continuing to cover more questions like this. If you like the content, please don't hesitate to subscribe to my channel. I hope you learned something today, and goodbye!